This is lesson 9.4, choosing a data display. The main thing to look at when choosing the data display is what type of data that you have. So you can see in this key idea from your textbook, you have all the different types of data displays that you've interacted with over the course of your mathematics education and what it does, and then an example of it. So when you're looking at a pictograph, you want to show data using pictures. Bar graphs show data in specific categories. Circle graphs will show data as parts of a whole, so anything that can be broken up into a fraction or percent. Line graphs will show data change over time. Histograms will show frequencies of data values in intervals of the same size. So the reason the bars are touching is because that interval is consecutive. So if it's like an age group, like 0 to 10, then the very next bar would represent 11 to 20. So it's continual. Stem and leaf plots orders numerical data and shows how they are distributed, but a lot of times it's only good for showing one type of data, like numerical, where you can order at least to greatest and look at it that way. A Box-and-Whisker Plot shows the variability of data set by using quartiles, so the information is broken up into 4 equal parts. The data plot shows the number of times each value occurs in a data set. It's probably more practical for smaller pieces of data. Scatter plots show the relationship between 2 data sets by using ordered pairs in a coordinate plane. And we've been working a lot with scatter plots in this chapter. So in example 1 from your textbook, to choose an appropriate data display for the situation, explain your reasoning. If you had the number of students in a marching band each year, you could choose a line graph, because the line graph would show the data change over time. Okay, so line graph would be appropriate. If you're going to compare a person's shoe size and their height, since you're comparing 2 different data sets, a scatter plot might make more sense because the data points might not necessarily fall in a straight line. However, we could make a line of best fit. All right. So if you were asked to choose an appropriate data display, this is the first one in your examples in your packet. The first question is the population of the United States divided into age groups. So hold on one second, let me look here to make sure. Oh, that looks pretty thin. All right. So for the population of the United States divided into age groups, because we're looking at the age groups and intervals, if you recall when I described the histogram. So for number 1, a histogram is a sample answer, and if you have a good reason for choosing another one, please include it. Because a histogram shows frequencies, right, within these age groups. Of ages in intervals of the same size. And the data points would be continual. For number 2, the percents of students in your school who play basketball, football, soccer, or lacrosse. Because the different sports are categorical, a bar graph may work. Okay, because it shows, bar graph shows specific categories. All right, but also, a circle graph, because percents are part of a whole. So when you're comparing them to the whole student body, you could see maybe the percent of students participating in each of the sports. Remember that the data displays are helping us to make the data more easily interpreted visually. The The next thing we're going to look at is identifying whether or not a display is appropriate. So I know that this turned out really small on this presentation and in the video, but if you open your textbook, I believe this example, this is example 2, and it's found on page 395. You can see it a little bit more up close. So what we have here is the number of hits your school's new website gets for 5 months. So it's a 5-month period from August, September, October, November, and December, and these are the number of hits. So when you just look at it, written down on that notebook paper, it's kind of hard to see visually, what is going on here. So if we use a graph, sometimes it makes it a little easier. So if we use a bar graph like in A, you look at the different months, you can definitely see the differences in the bar heights. The intervals are all equal on the number of hits side, so it's not misleading in any way, and it is appropriate. So yes, a bar graph would work. B, trying to fit the data into a histogram would be like taking the hits and trying to break it up into equal intervals, but that doesn't really give us that many. So we've taken and we've gone from 0 to 399, and there are two values, August and September, that fit in that, but it doesn't give us enough information, does it? Because it's kind of blurred the lines here. Whereas in part A, we can see that December had the most hits, but in part B, we can't see that information. So it doesn't show the number of hits for each month and how it's changing over time, so it's not appropriate. And then when you look at C, the line graph, again, broken up into each month individually, the intervals are all the same, so we can see that the hits are changing over time and it would be appropriate. So now what we're going to do is look and see if we can take the same data from the number of hits in these months and try a few other displays and whether or not they would be appropriate. So looking at the data, we want to look and see if we can make it into a dot plot, a circle graph, or a stem and leaf plot. So again, we have the months, August, September, October, November, December, which on a dot plot would probably go along the bottom. The hard part about a dot plot is you would have to make 250 dots. So the data points and the hits are just too high of a number to use something like a dot plot, right? Because then the other side of it is it won't show it changing over time. So a dot plot would not be the most appropriate. Notice how I switched to a typed answer because it's a lot neater than my handwritten answer. So maybe it'll be easier for you. A circle graph. So if we're looking at a circle graph and now we have our months, right? How could we change this data into something that would show percents? Well, if we took the number of hits and we totaled them up and compared it to the total number of hits, each month could be a different piece of the circle graph or the pie chart, and then it would be representative of a fractional part of the total or a percentage. So yeah, a circle graph would show the fraction or percent of the total number of hits for each month, and then this would definitely show us how it's changing over time because December would be given a greater percentage of degrees in the circle. And then again, a stem and leaf plot, to put those numbers in order least to greatest and then put them on there would kind of blur the lines because we wouldn't really know which one goes with which month. So it's not going to show it changing over time. So that's why the stem and leaf plot would not be the appropriate choice. So you get to determine whether you think it'll be appropriate or not in some of the examples in tonight's homework. Okay, moving on to identify misleading data displays. So both of these two graphs are showing a line graph of box office revenues. If you look on the left, there's a break, and sometimes that's an appropriate thing to do, but if you notice that what's happening is it goes from 0 to 8, and then it starts counting by ones. So what it has done now is it has changed the vertical axis, all right, so that it shows that the graph is appearing to have a rapid increase from 2005 to 2009. But the one on the right, has an unbroken axis, and it's a more honest and shows the amount of revenue increasing slowly. Therefore, it's not misleading. You can tell the difference in the slopes. So the graph on the left is misleading. So now another part of this example is a volunteer concludes that the number of cans of food and boxes of food donated were about the same. Is this conclusion accurate? Well, looking at their pictograph, it sort of appears to be because cans equal 20 cans, boxes equal 20 boxes, and bottles equal 20 bottles. And if you look at the distance, to the far right, the boxes are almost as far as the cans. It may appear to be true, except for the numbers are not the same because the sizes of the icons are different. So make sure that if you are using a pictograph that you use the exact same type of icon in the pictograph so that things are not distorted. So the conclusion is not accurate because if you really look and count them, the number of boxes is about half the number of cans. So that's not a good display. So now we're going to be asked to find some, explain why the data may be misleading. So if you look at the concert ticket prices, the concert ticket price in dollars and rock band A, rock band C, B, and C, you see a break in the vertical axis. You also see a difference in the width of the tickets. And both of those are going to make it misleading because it appears that the difference is much greater than it actually is. In 7, the company profits because the profits are going to be in billions of dollars. There's no break in the axis, but if you look at the years, the width of the bar changes. So the wider bar makes it look like the increase is greater when actually it's less than 5. So look for ways and describe them in words why you would think that the data display is misleading.